Good morning, everyone. So, welcome you all in today's class. We are doing chapter number 8, Quadrilaterals. Before starting today's topic, that is the midpoint theorem, let me recapitulate the last question of exercise 8.1. That was a very important one. Most of time, question 12, that is of 12 marks. Question number 12, exercise 8.1. Yesterday I have discussed in detail. One trapezium is given, right? And in this trapezium, your AB is parallel to CD. This AB is parallel to CD, right? And what is given? That AD and BC are equal. AD, this is also given. Now here we have to prove angle A is equal to B, angle C is equal to D. So here it was given. We have to produce this AB further here, right? Straight line, and from A like AD, we will draw a line parallel to it. That this point is point P. Now if this side AD and these are equal, so ABCE is also a parallelogram. And when it is a parallelogram, so opposite sides of a parallelogram, they are also equal. So here AD, BC and CE, they are equal. Now what we have? BCE is an isosceles triangle, so these angles must be equal. Angle X, and the parallelogram, that is AECD, opposite angles must be equal. So this angle is X, adjacent angles are, and here linear pair, that is 180 minus X. So what we have proved? Angle A is equal to angle B here. Angle A and B are equal. Similarly, this angle is the alternate angles. Why? AB is parallel to CD, so this angle is X, this angle must be X. These are the first two parts, and third and the fourth part, we have to join A with the two triangles, that is triangle, here one is AB, one is ABC and one is AB, right? One is triangle ABC, ABC and another is BAB. These two triangles, so first part, which we want to prove here, that is triangle ABC and BAB. Sides, that is here AD, BC and AD. That is BC and AD equal. Here is BC and here is AD. They are equal. And angle A is equal to, in this triangle, this angle A and this B, they are equal. And the third, AB is equal to BA. AB is equal to BA common. Therefore, triangle ABC is congruent to triangle, right? How we have proved? By side angle side rule. Side angle and side rule. By side angle side rule, triangles are congruent, and this is the third part which we want to do in this question, whereas the fourth part We want to prove here AC is diagonal AC is equal to BD. So why it is so? By simplicity. Corresponding parts of congruent triangles are always equal. So let's have a little very less students, those who are live. So many students they have sent the attendance, right? So Ashdeep Singh, very good morning. Harjot Kaur, Varnit, Harshita, then Savan Singh, very good morning. So you all are requested to please attend the classes. These are very, very important topics. Today we will discuss that midpoint theorem and the converse of midpoint theorem, right? So let's begin. Midpoint theorem. Start with one activity. Draw any triangle. What is the activity? Draw any triangle ABC or name it. Here geometry box is very, very important. Your scale, compass and the pencil. If it is a triangle A, B and C, now locate the midpoint of AB. Let this point is P or let is E. AB is equal to B midpoint, and here also is the midpoint F. Take E and F as the midpoint of this triangle. Join E with F. What we have taken in this activity, we have chosen one triangle, and for two sides we have taken the midpoints of the two sides. That one side is AB and one side is AC. E is the midpoint of AB and F is the midpoint of AC. Join E with F. Now we will find when we measure these two angles, the angle AEF is always equal to, that is ABC. First thing you can measure, what is AEF and ABC, they are equal angle, or you can say like of the corresponding angles. Okay. So here what we will, now you will find that EF, first thing, EF is parallel to BC, right? What is it? EF is parallel to BC, and you can repeat this activity. Second, you can measure the length of EF and BC. You will find that always EF is equal to half of BC. What is EF? EF is half of BC. So this activity you can perform so many times, and you will find that if any triangle is there, if I am taking one triangle and I am choosing taking the half, let's take this side also. If I am taking this is the midpoint, this is the midpoint. If I am joining that this is P, Q, R, and this is X and Y. X and Y are the midpoints of these two sides. When I join X with Y, right? X with Y, what I will found? I will found that X, Y is always parallel to QR, and X, Y is equal to half of QR. Always. In another way, if I am taking one more triangle, right? So here if I am taking the midpoint of this side, midpoint, and this side midpoint here. When I join it, that this triangle is triangle DEF, or and the points, this is B. So always you will find that B and G are the midpoints of the sides. You will find that BG is always parallel to HI and it is half of it. So here we will come to a very important theorem that is called midpoint theorem. What is called midpoint theorem. So midpoint theorem and its converse, that is very important. So start here, place the midpoint theorem. So here this is the activity for you. You can repeat the activity and you will find always when you join in any two sides, when you take the midpoints of these two sides, joining these two midpoints, the line segment EF is always parallel to this third side, and this EF is always parallel to BC and EF is half of BC. So this is the midpoint theorem. Write down the statement. So here we have Ajay Veer Singh. Very good morning. Abhijot Singh. Good morning, Ajay. So welcome you in today's class. And this is a very important topic. Midpoint theorem and its converse. So let's begin. Write down the statement theorem first. It says that the line segment joining the midpoints, the line segment joining the midpoint, the line segment joining the midpoint of two sides of a triangle, right? A line segment joining the midpoints of two sides of a triangle is parallel to third side and is half of it. Parallel to third side and is half of it. Same, you can choose any triangle that is ABC. Same diagram that is ABC. First one I have discussed. Let's choose. This is the midpoint E and F. Join E with F. So midpoint still says that if E and F are the midpoints, of two sides, then EF parallel to BC, and always midpoint theorem says EF is always parallel to BC and EF is equal to half of BC. This is the statement of your midpoint theorem. So we will go for its proof, and it is given in the book. We will go for the proof. What is midpoint theorem? In any triangle, when we join the line segment joining the midpoints of any two sides of a triangle is always parallel to the third side, and this line segment is always half of the third side, right? So this is the statement of your Bitcoin theorem. Now it's proof, and then we will go for its converse. What is the converse? When we draw a line from one point and parallel to third side, definitely it will pass through the midpoint of the third side. Okay. First we will prove midpoint theorem, and then we will discuss its converse. Right. So this is the statement of midpoint theorem. Right. So its proof. For proof, we can draw one triangle, right? A, B, and C, and these are the midpoints E and F. What we can do? We can draw one line parallel to AB. By construction, draw. Here, what is the proof we want to prove? Here, this is to prove. EF is parallel to BC and EF is half of BC. Where this E and F, they are midpoints. E and F are midpoints of the triangle. So what I have discussed? I have discussed the midpoint theorem, that the line segment joining the midpoints of any triangle is always parallel to the third side, and this EF, the line segment where joining the midpoint, is always half of third side. Confirm. So its proof we will take. Go for its proof. We will, by construction, we will draw one line parallel to AB. AB is the line. From point C, we will draw line parallel to so it is E. You can choose any other point. That is point is M here. CM is parallel to AB by construction, right? By construction, we can produce this EF further. Let this point is what? D point. Now, try to understand EB and CD, they are parallel, right? And we have already discussed about the properties here. We want to prove EF is parallel to BC, and so here we will go add with these two triangles. One is triangle AEF, and another triangle, because here this angle is no down, and these angles are alternate angles. This angle and this. See one thing, AE, already we have AE is equal to BE, and AF. Why? Because E and F are the midpoints of these sides. E and F are the midpoints of these sides. So here, one is triangle AEF and another is CDF. So another triangle is your CDF. Now we will prove these two triangles congruent. How? One this angle they are equal. Why they are equal? Because they are alternate angles. They are alternate angles. Why? Because AB is parallel to what is AB is parallel to CM. By construction we have done, and these are vertically opposite angle. And whereas AF is equal to, so angle side angle rule, the triangles are what? Congruent by side, sorry, this angle side angle rule. Right? By angle side angle rule. By angle side angle rule. Angle, this is the side, right? Because F is the midpoint of AC also. So by angle side angle rule of congruence, these two triangles are what? They are congruent. And what? By simplicity, what we have here, EF is equal to DF. EF is equal to DF. By simplicity, in book you will find there saying y. It is up to you what logic you have. By simplicity, your EF corresponding is equal to DF, right? Now EF is equal to DF, but here what is it? EBCD is a parallelogram, because already this is half of it. So this is, we know that already your E or BC so here, why it is a parallelogram? Why it is a parallelogram? See, EF is equal to FT. How we will prove it? EF is equal to DF, and EF plus DF is equal to what? ED. ED is equal to BC, right? So here the reason and the logic they are important one. BCDE is a parallelogram and BE is equal to AE. BE is equal to AE. BE is equal to AE, and it is further equal to your BC also. That's why already by construction we have taken AB is parallel to CM, AB is parallel to CM, and here EF is equal to DF, and by simplicity, what we have, by simplicity, these two triangles, that is BE, because AE is equal to what? BC. AE is equal to BC. AE is equal to BC here. By simplicity, what we have, we also have AE is equal to your CD or DC, and this is further equal to BE. Here we have this one. What is AE? AE is equal to BE. So therefore, from this statement, we have that this BCD is a parallelogram. Let me repeat again. Once we have proved the triangle AEF congruent to CDF, these two triangles are congruent by angle side angle rule. Right? Now triangles are congruent. CPCD says EF is equal to FT, and BE. Already we have BE is equal to AE. BE is equal to AE. But here simplicity says that AE is equal to BC. AE is equal to, this is AE is equal to BC. AE is equal to BC. And it means BE is equal to BC. If BE is equal to BC, BE is equal to DC, and already we have written BE is parallel to DC. This is the sufficient condition for the parallelogram. This is the sufficient condition to say that BCBE is a parallelogram, right? And once it is a parallelogram, it means what we have ED is equal to BC, not ED, yes, ED is equal to BC, opposite sides, and ED is parallel to BC. Why? Because it's parallel. So also, we can write that EF already we have is equal. So this is the proof of midpoint theorem. Very, very important, right? This is the proof of midpoint theorem. Okay. Tomorrow again in the beginning of the introduction I will recapitulate. Okay. Because now we want to proceed for the externals and then we will carry on the topic. So here let me discuss again. We want to prove that EF is parallel to BC and EF is half of BC. So by construction, we have drawn one line CM which is parallel to AB. Now these two triangles, triangle 1, triangle 2, we are putting congruent by angle side angle rule. These two angles are alternate angles, and this angle and this angle they are vertically opposite angles, and the side AF, this is already given because F is the midpoint, AE is equal to BE, so we are using both here. By simplicity, what we have, BE is equal to BC, so AF is equal to CF. Here is EF is equal to DF by simplicity 1. Another, we have proved that AE is equal to CD. AE is equal to CD, and already we have here AE is equal to BE. So we have this statement. And then we came to know that this BCD is a parallelogram. Once it is a parallelogram, so ED is parallel to BC and so opposite sides, and then this is. So I hope this is clear to very, very important one, and application also. Now come to the external words. Midpoint to converse. Converse is if we are drawing one line A, B, C is a triangle and this is the midpoint, it is given. That this point E is the midpoint, and if I am drawing one line which is passing through this point and parallel to BC, what is the converse of midpoint theorem? If we have a line L is parallel to BC and passing through the midpoint E, right? And passing through one of the midpoint E, where E is the midpoint, where E is the midpoint, then this line L divides these other sides into equal parts. Then next point is F. AF is equal to CF. This thing will be there. That this line which is drawn parallel to the one side will always pass through the midpoint of the third side. Right now? So here the converse is a line drawn through, right on the statement. I hope you understood here. This is the point B and C. The converse is a line drawn through the midpoints of one side. The line drawn through the midpoints of one side of a triangle, and parallel to the third side, parallel to the another side bisects the third side. Parallel to the another side bisect means two equal parts. Bisect means two equal parts. What is it? If we have a triangle and any line which is passing through the midpoint, that this line is the line which is first, this line is parallel to this side, right? And this is the midpoint, let E here. So definitely this point F will also the midpoint. So statement of the converse, when a line is drawn through the midpoint of one side, this is the one side here, AB is the one side, parallel to the another side, bisects the third side, right? So what is the converse of the midpoint theorem? A line drawn through the midpoint of one side of triangle parallel to another bisects the third side, right? So here what we have, what is given here, L line that is parallel to your BC and E is the midpoint, and we have to prove midpoint of AB, and we have to prove here, if we want to go for its proof, what we prove? We will prove F is the midpoint. AF is equal to CF. What we want to prove? AF is equal to CF. So sometimes converse of the midpoint theorem, that is also in the exam, right? So for the converse of the midpoint theorem, again we have to draw the diagram in the same way. Its proof, again draw line parallel. This is line L, A, B and A. That is the line point M here, and same this is here ABC is a triangle, and this is the point D here. By construction, we have drawn AB is parallel to CM. Already, line L is parallel to BC, and what we have AE is equal to AE here is equal to EB. And to prove what we want to prove here, we want to prove that AF is equal to CF, or F is the midpoint. This is the converse of midpoint theorem. How to prove it? Again, we will choose these two triangles. These two triangles are triangle AEF and CDF. One is triangle AEF, another is CDF. So here these are vertically opposite angle, but here we will not write this one because this thing we want to prove here, right? And these two angles are alternate angles, right? Now BCDE is a parallelogram. Here by construction BCDE is a parallelogram. Now it is a parallelogram, so opposite sides of parallelogram are what? Equal. Therefore, triangles are congruent by angle side. Which side? That is AE, which is equal to already BE. So AE is equal to what? That is CD. AE is equal to CD. So by angle side rule of congruence, these two triangles are congruent, and therefore what we have? We have by simplicity AF is equal to CF. What is it? AF. This is your AF and this is CF. By simplicity, or F is the midpoint. So this is the converse of your BPT. Okay, so not BPT is midpoint theorem. BPT, that is basic proportionality theorem, we will do it later. So I hope it is clear. Tomorrow again, I will in the beginning I will recapitulate again. Okay, and switch over to your example number 7. That is also very important based on your midpoint theorem, right? If I have to recapitulate again, what I have done here, I have chosen these two triangles. One is AEF and CDF. This angle and this angle are vertically opposite angle, and these two angles, angle A and C, alternate angles. And here already we have, this is the parallelogram, and in a parallelogram the opposite sides are equal, and by using this parallelogram already E is the midpoint given. So here we have proved A is equal to C. Triangles are congruent by angle side rule. By simplicity we have AF is equal to C. Okay. So switch over to example number 7. This is also very important. Example number 7 is a very basic example and very important one, because it is totally based on your midpoint theorem. For any triangle, if you have any triangle and here triangle is like ABC and D respective midpoints of this triangle, then we have to prove when we join them, when we join D with D, F with E, and D with F, we have four triangles and all these four triangles are congruent. So we have to prove in this example all these four triangles congruent. So question is very important, totally based on midpoint theorem, application of midpoint theorem. So how to apply what is given here in this triangle ABC, D, E and F are the midpoints of the sides AB, D is of AB, E is of BC and F respectively. Respectively means first D is of AB, E is of BC and F is the midpoint of AC. Now what we want to prove? We want to prove these four triangles, they are congruent to each other. And always you can draw any kind of triangle, you can choose any triangle, right? Any triangle, when you join their midpoints, right? You will find that the four triangles, they are always congruent. Triangle 1, triangle 2, triangle 3, triangle 4, how they are congruent? We will always have a kind of a parallelogram. That means this side is always parallel to this side, midpoint theorem says, right? And diagonal of a parallelogram divides the two triangles which are always congruent. Same, this is also a parallelogram. This is the main logic we will apply here, right? So here also, what is the solution? Midpoint theorem says, by midpoint theorem, DE is what? DE. Now what we have? We know D is the midpoint of AB, DE, E is the midpoint of BC and F is the midpoint of AC. So here, what is DE? D is parallel to AC and DE is equal to half of first. Second, EF, that is parallel to AB this is the statement of your midpoint theorem. Even here, what is DF? DF is parallel to BCF and DF is equal to half of BC. All these three statements, they are the statement of midpoint theorem. Midpoint theorem says that when we join the midpoint, when we join the DE as the midpoint, so this is always parallel to AC, the third side and parallel and half of it. Now what we have? We have like here B, E, F, D. This side is always half of it, right? And this is the half of them. So what we have? We have B, E, F, D is a parallelogram. Why it is a parallelogram? Look here, BD is equal to EF and BD is parallel to EF. It is the sufficient condition to for a parallelogram. Opposite sides, one pair of opposite sides are equal and parallel. But here this side is what? EF DF is equal to BE because it is also half of it. So opposite sides are equal as well as parallel. So here B, E, F, D is a parallelogram and diagonals divide the parallelogram into congruent triangles. Right? So here triangle naming is very important now. If you are writing it B, D, E is congruent to F. See, B, D, E, and it is F, E, D. Why? Diagonals of a parallelogram. Similarly, what we can write? Similarly, what we have? D, E, C, F. DECF and we have ADEF. They are the parallelograms, right? Again, DECF is a parallelogram and EF is the diagonal. So here triangle 1 and triangle 3 they are also congruent. Why? Because diagonals divide the parallelogram into congruent triangles. But how to name them? So name one is triangle. If I am studying the triangle that is CEF is congruent to cross this angle and this angle. That is triangle CEF. So here we have to start with DFE. Similarly, triangle 1 is congruent to triangle 4. How to name them? If I am taking triangle 1, that is DEF only. That is DEF, or if you want to take it as DEF, then according to its name. One more thing very important I want to discuss here. If you are naming it as this DFE, same triangle DEF. So see how the name will change. D with C, confirm opposite angles. Here E. So E with F, right? And F with E. So name will change. You can write it any way. And whereas 1 and 4, that is DEF, is congruent to triangle, that is DEF, right, is equal to F with D angle, that is angle F here, and E, that is angle A. So here F, A. These four triangles, they are congruent to each other. So naming is very, very important, right? So go ahead. Today we have discussed the midpoint theorem and its converse and the question example number 7. They are very, very important. So we are left with one example, that is your example number 8, and exercise, last exercise, that is 8.2. Only 7 questions are there. Okay, and then you have the summary of this chapter. You can write at the end of the chapter summary, right? All points they are discussed, right? So go through these 3 things. One is the midpoint theorem, then the converge, and the example number 7. With this, thank you very much. Work hard. God bless you. Stay safe and stay healthy.